Dear viewers, in my previous video, I was explaining about the template that need to be followed when we do a QFD, or in other words, House of Quality. QFD stands for Quality Function Deployment, or the other name for that is House of Quality. And House of Quality as a tool used to convert customer requirement into technical requirements, which can then have a target for itself, and the design team can consider the target when they are coming up with a new design. And that design will be in a position to satisfy customer requirements. So this is what QFD as a tool is all about. So in this video, we will understand how to do a QFD, or I'll explain you with an example of how to do a QFD for a product industry. Let's get into the video. As I was explaining, this video is about how to do a QFD for an electric scooter. So if I am a company which already have an electric scooter, but I am trying to come up with a new one, a new model, or I am a company where I do not have an electric scooter, new to the business, and I want to come up with a new scooter. In both the cases, to support my design team, I can do a QFD exercise to understand customer requirements, and based on the customer requirements, how QFD tool converts it into technical requirements and it targets, we'll be able to use those insights in our design phase, right? So let's understand from the fundamental requirements of a electric scooter. So if you go on people and if you go and ask people the potential users of electric scooter, what would you like to have in your electric scooter, then people will come up with a lot of requirements. Maybe for the example purpose, I have restricted to 5 requirements, but you will have a lot of requirements. Requirements like my vehicle should be stable while driving. Requirements like it should have a high range. So in electric scooter industry, range means when you charge your battery fully, how many kilometers it can give you a ride, right? One full ride for one full recharge is what in electric scooter industry we call it range. So I want high range. That means if I charge my battery once, I should be able to drive 70 kilometers, 80 kilometers, 90 kilometers. That is what we call it as a range. Then some of the customers also told I need a very good dashboard, a Bluetooth enabled dashboard, like how you see in a car. I should be able to have so many information in my dashboard. So that is a requirement of a few customers. Then some customers say I want my battery to be charging faster. That means I don't want to charge my battery for a longer period. I want it to be charged faster so that the usage or utilization of my vehicle can be better, because if it's continuously charging, I'll not be able to use my vehicle. So less number of hours or less number of minutes for a full charge is fast charging. Then longer battery life. I need to have my battery for say 1 lakh kilometers, 1.5 lakh kilometers, 2 lakh kilometers. So these are customer requirements. And as I used to explain in my previous videos, once you have the requirements gathered, then we need to convert that, or we need to give importance rating to the requirement. So what I have done, I have given an importance rating here. Stable while driving is a safety parameter. Definitely customers would give 5 out of 5. High range is also a safety parameter. Definitely customer would give 5 out of 5. Long battery life is a cost related parameter. Again, definitely customer would give a 5 out of 5. In fact, a high range also is a what I should say, cost related parameter. Maybe a Bluetooth dashboard, not such critical, hence I give 3. Faster charging, maybe if you want to have a trade-off between faster charging or better or longer battery life, maybe you will go for the second one. I'm willing to wait for 30 more minutes, but if I can get another 20,000 kilometers from my battery, I would be preferring that option. So that's how I given this rating, completely up to your customer and the product that you are dealing with. This is just an example. So section 1 filled, section 2 filled. Now we will come to section 3, and the section 3 talks about my technical requirements in a electric scooter. So I need a battery capacity. So battery capacity is one thing which is very important to decide some of my requirements. Power of my motor. What is the power of my motor? How much power it is going to generate? Aerodynamic design of my electric scooter. It has something to do with your vehicle being stable while you are driving, not vibrating, being stable. Tensile strength of the material that you use, that also have something to do with your range as well as with your stability while driving. Weight has something to do with stability, and it also have something to do with um, high range and digital capabilities. So what are the digital capabilities my electric scooter have? That has something to do with your Bluetooth dashboard and few other things. And battery size, how big is going to be my battery? That also have something to do with some of these customer requirements. So this is what I have filled. And once I fill this, then my improvement direction. Battery capacity, higher the better. Motor power, higher the better. Aerodynamic design is basically you can use design A or design B or design C if there are three designs available. So I have called it nominal, so you can choose to have any of that. Tensile strength, higher the better. Vehicle weight, lower the better. Digital capabilities, higher the better. Battery size, optimal the better. You don't want a too smaller a battery, and you also don't want a too bigger a battery. You want it optimal, right? Optimal the better. So this is the improvement direction. And once I have done this, then what I need to do is I need to give a interaction rating. So how do I give interaction rating? Let's see that. So here, does battery capacity anything to do with stability while driving? Actually no, so I'm leaving it back. Does battery capacity have anything to do with high range? Definitely yes, so I give a 9 out of it. We have already discussed when do we give 9, 3 and 1. 9 for very high interaction, 3 for moderate interaction, 1 for low interaction, and the cell will be left to blank or considered 0 if there is no interaction. So battery capacity has nothing to do with the vehicle being stable while driving, but battery capacity have a high interaction with the high range. Battery capacity have nothing to do with the kind of dashboard you have, but battery capacity have very high interaction with faster charging and longer battery life. So if you see here, whatever I have entered, 9, 9 and the 2 columns left to blank. Motor power, stability while driving, motor power may have a moderate impact. Range, definitely high impact. Longer battery life, maybe motor power have a low impact. So similarly, if you want to see this digital capabilities, Bluetooth dashboard, definitely your digital capabilities have a very high impact. Longer battery life, your digital capability also have a role to play in longer battery life, but a moderate role, right? Battery size have a low impact on your stability while driving. So we fill this column by asking a question for ourselves: how does this technical requirement going to impact your customer requirement? So in a scale, we measure it at 9, 3, 1 and leaving it blank. 9 stands for very high impact, 3 is for moderate, 1 is for low, and leaving blank is for no impact at all. And once we have done this, now we need to fill the roof. So this is where it becomes important. So how do we fill this roof? So here I have a double plus. Let me make it visible. Yeah, here I have a double plus. Now the question is, does battery capacity have anything to do with battery size? Yes. If battery size become bigger and bigger, battery capacity also becomes bigger and bigger. Okay, great. Does battery size have anything to do with digital capabilities? No. Does battery capacity have anything to do with weight? No. Does battery capacity have anything to do with tensile strength? No. Does battery capacity have anything to do with aerodynamic design? No. Does battery capacity have anything to do with motor power? Definitely yes. So I take this first column, then come from here. So each of this talks about how is this particular technical requirement have a correlation with others. So the meaning of correlation is, if you make a decision on this, it will impact this and it will also impact this. You cannot make a separate decision on this. When you make something or when you decide to do something on this, it will have a strong impact on these two. That is what we called it by correlation. So next, what we need to fill, motor power. So already motor power and battery capacity is covered here. So we are going to cover the remaining part here. Does motor power have anything to do with aerodynamic design? No. Motor power have anything to do with tensile strength? Maybe I will put a single plus, because you have a strong material, then only you can have a strong motor. On a weak material, you cannot have a strong motor. Okay. Does motor power have anything to do with the sorry, I made a mistake. Does motor power have anything to do with the tensile strength? It should be in this column. Yes. Yes. Does motor power have anything to do with the weight? Yes. Does motor power have anything to do with the digital capabilities? No. Does motor power have anything to do with the battery size? Yes. In fact, a very strong correlation. So I put a double plus here. Okay. Aerodynamic design. Does it have anything to do with weight? Yes. Weight becoming lower and lower, or weight on a negative correlation, can give you a better aerodynamic design. So I put a minus. So friends, what I enter here, maybe to your logic, if this is not correct, that's still fine. This is only a example. Maybe a much better subject matter expert would be able to give a better rating here, but what I'm trying to explain is only from a example perspective, right? Aerodynamic design with digital capabilities, yes, a better design. Okay, I think aerodynamic design with weight, yes, and aerodynamic design for better digital capabilities, yes, there is a moderate positive correlation. Better design, better digital capabilities, or the other way around, better digital capabilities, better design. And tensile strength, maybe I can put a double plus here. Tensile strength has something to do with, here is a tensile strength. Tensile strength does definitely have something to do with weight. And weight has anything to do with digital capabilities of battery? No. So this is how we fill the roof, and as we fill the roof, you will understand it explains the correlation between technical requirements of the, or it explains the correlation among the technical requirements among each other. And once you fill this, this gives you an idea of when you touch some of these requirements, this will definitely have an impact, positive or negative correlation with other requirements. And once this is done, then we come down to the section on the right which talks about competitor analysis. Now in competitor analysis, what do we fill? If I have an existing version of an electric scooter, I will try to rate how customer view my particular electric scooter in stability while driving. The current version scores only 3 out of 5. High range, it scores 4 out of 5. But my competitor current version, the stability is 5 out of 5, and competitor B, it is 4 out of 5. So what does it tell? I need to come up with a new design where it should score 5 out of 5 to be competitive in the market. So if I don't have a current version, I can leave this column blank and I can have only the competitor A and B filled. If I have a current version, I can fill this, and from this I can take a target on each of this, what I need to achieve. This product should achieve what kind of customer rating in these requirements. So that is what this section all about. And once I have done this, now I come down to the importance weighting. Now this importance weighting, as I explained in my previous video, this is a very important stage, because this is where you are creating a sum product of your customer requirements rating, that is importance rating, and your interaction rating that you have given for this technical requirement against the customer requirement. So for example, battery capacity did not have any kind of interaction, hence we left it blank. So 5 multiplied by 0 plus 5 multiplied by 9 plus 3 multiplied by 0 plus 4 multiplied by 9 plus 5 multiplied by 9. So this value in Excel can be calculated using a formula called sum product. And if you do a sum product, select the first array and then comma, select the second array, you get the sum product value. I have repeated the same for all these individual columns, and by that I have calculated the overall total, and the total is 577. Now I have to come up with something called relative importance rating. And how do we get relative importance rating? Relative importance rating is basically 126 divided by 577. So 126 divided by 577 gives me the relative importance rating, and the relative importance rating for this, all these requirements, technical requirements, have calculated. And what is the benefit of calculating it? Whichever relative importance scores high, that particular technical requirement plays a very important role in satisfying these customer requirements. So by that way, battery size have a very high impact of 22.7, followed by battery capacity at 21.8, and followed by weight of your electric scooter at 16.5, and then you have tensile strength and motor capacity together at 11.3, aerodynamic design at 9.2, and digital capabilities at 7.3. This is the impact of the technical requirements on the customer requirements. So that is what we have calculated here. Now what we are going to do is we are going to enter measuring units. So what do you mean by measuring units? Each of these technical requirements, what is the unit in which it get measured? So battery is measured in amps per hour or AH. Motor power is measured in PSI, or whichever way motor pressure is getting measured. So in my example, I have taken it as PSI. Then you have aerodynamic design index. So you do not have a direct measurement. So depending upon, there could be some kind of rating agencies or some kind of industry bodies which assess each design and give a score. So that is aerodynamic design index. Tensile strength is again PSI. Weight is kilogram. So motor could be horsepower depending upon how you want to measure it. So it could be horsepower. Weight is kilograms. Digital capability index and battery size cell. So in this, the next column will talk about what is our value. That means, as I was explaining from the beginning, if I already have a current model, how does my model feature in all these technical requirements in the measuring unit? 12 amps, 120 psi, tensile strength 350 psi, aerodynamics index 3.5, 3.8 out of 5, digital index 4 out of 5, cells 21.7 K cells, right? Kilogram 62.3. So this is your current score or your model's current score. And what you do, you also do some market research and try to get what is the score of your competitor A and competitor B, your two nearest competitors in these two or in these 7 requirements. And once you have identified this, from here you will take a design target requirement. So the design target requirement will be, I need to have a electric scooter whose battery capacity is 20 amps per hour, AH, motor power of 150 psi, aerodynamic index of 4.25, tensile strength of material, tensile strength of the material in which it is going to be built with 400 psi. The vehicle should be weighing only 65 kilograms, and the vehicle should have a digital capability index of 4.5, and the battery size should be 22.5 K cells. And once I've taken this, I'll be able to give it to my design team, and my design team will be able to take this as my design targets. And as I told, if the design target is higher the better or lower the better, it will have its appropriate one-sided specifications, and if it is optimal the better, it will have its appropriate two-sided specifications. And if it is nominal the better, then it will have what are all the different options. By nominal I mean you can either go for design A or design B or design C, right? So by that way you will be able to get your target requirements, and this can be used in your subsequent design framework. When you're planning to come up with a new design, this can be used. Friends, I hope this example was useful for you to understand how QFD as a tool can be used in a product industry when you want to come up with a new design. In my next video, I'll be explaining how QFD as a tool can be used in a service industry when you are planning to come up with a new service offering. I hope this video was useful. For more videos on Lean Six Sigma design tools, Lean Six Sigma quality management tools, and Minitab tools, techniques and tutorials, please subscribe our channel. Thanks for your time. See you in another video. Thank you.